In exercise 3.1, we are introduced with explanatory versus response variables. This is pretty much the start of bivariate data. And before we get to explanatory versus response variables, let's just review what bivariate data means. Bivariate data is when we compare two variables and we describe their relationship and their association with each other. And we can sort of diagram their relationships through scatter plots, and we can use a least squares regression line or a line of best fit to sort of describe how strongly correlated the two variables are, which is what we later investigate in exercise or chapter 4 and 5. So, for example, if we're talking about bivariate data, we've usually got two variables, i.e. height and weight. And here height would be explanatory and weight will be response. We're going to take a look at why as we go down the list. So the next part of understanding explanatory versus response variable is once we know that we're comparing two things or two things that change, we need to investigate what variables mean. Literally, variables are just things that can change, okay? And in the past, you might have learnt these as pronumerals. In science, it'll be called variables. In math, it was usually called pronumerals. But basically, they're just categories which can change and fluctuate, and we can see that example up top with height and weight. Obviously, we have people of different height and people of different weight, and so that's why I guess the data in those categories can change. The next part to understanding explanatory and response is literally explaining their two relationships with each other. So if you do science or if you've learnt math in the past in the old curriculum, you might know explanatory variables as independent variables and response variables as dependent variables. So the response variable is always reacting to the changes in the explanatory variable. So in other words, response variable would be on your y-axis, your explanatory will be on your x, where the x-axis is up for you to sort of change, and then the y-axis or the response variable will react to the changes on the x scale. Sounds pretty complicated. Let's talk about an example. So think about the time you spent studying and your subject score at the end of the year. Do you think there's going to be a relationship between the two variables? If you said yes, you're spot on, okay? Because the time you spend studying is ultimately up to you, okay? The more you study, generally speaking, the better your study score will be at the end of VCE. So that's why how long you study will affect your study score at the end of the year. That's why the time you study is your explanatory variable, and that's why your study score is responding to what you do with that time, right? And how much you study. So if we were to try to phrase this the other way, is your study score going to affect or change? Sorry, is your study score going to change the time you spend studying? No. Okay, once you have your study score, that's done. Okay, you can't change the time you're studying. Okay, it doesn't make any sense. So the amount of time you spend studying will directly affect your subject's study score, okay, at the end of the year. So that's why the study score is responding to the time you put in. I'm hoping that makes a little more sense. And if we were to graph this, what we would have is so imagine we've got a scatter plot, which is what we're going to investigate later on. Here on the y-axis, what you would have is study score. So subject study score. And on the x-axis, you're going to have time spent studying. Okay, and later on, we're going to take a look at, I guess, scatter plots. But imagine if this is your study score at 0. At the top there is 50. Let's say time spent studying per day, because we need a unit, or hours per day. All right, if you spend 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, so on and so forth, you can expect that if you spend no time studying each day, your score could be anywhere from 0 to maybe in the 30s if you're naturally talented. But as you study more and more, you can expect sort of a trend to occur where your study score is going to get higher and higher. Okay, it doesn't necessarily guarantee you a 50, but you're going to get an upwards trend where if you study 2 hours a day, maybe you're going to guarantee yourself a 30 at the end of the year. But remember, each one of these dots would represent a person in this scenario where, a person might have studied 3 hours a day, and for further math, they might have gotten, a 34 study score, whereas a person might also study 3 hours a day and get a 27 study score, or they might even get a 50. Okay, so this is why we have sort of this dotted spread. Each dot represents a person, and then later on, as we investigate scatter plots, we can see how strongly correlated or how strongly connected two variables are to each other, depending on how spread these dots are. But exercise 3.1 is literally just identifying explanatory and response variables. Let me know if you have any questions, but that's it.